So good evening or good morning, depending on where in the world you are. My name is Julia Barbareschi. I am a research fellow at the Keio Graduate School of Media Design in Yokohama. And I'm also an honorary lecturer at the University College London. So today I want to talk to you a little bit about different projects that I had the opportunity to work on, and they're about different kind of accessible technologies or assistive technologies, and they're spread a little bit around different areas of the world. I've been very fortunate. So I am originally from Italy. I am actually a physiotherapist by background, but I did my doctorate in London at the University College London. And I had the opportunity to work on assistive technology design and testing. I've been very fortunate in having opportunities to work in projects in different areas of the world. I worked in the US for a little bit, of course, the United Kingdom. I also spent some time at the World Health Organization in Geneva, and engaged in a series of projects in the Global South, primarily in East Africa, in India, and in Bangladesh. And since 2021, I moved to Japan to conduct my research here. So I will touch on a couple of projects, trying to pick from different contexts, but also different type of projects that engage different people. I also like to put a disclaimer that although I title the talk Accessible and Assistive Technologies, what I really care about is people. Don't get me wrong, technology is cool, but I think that sometimes what happens is that we get carried a little bit away with stuff. And we tend to focus on technological means, whereas technology is just a tool, and it's only as good as the person who's using it, and is how useful or how meaningful it is depends on the person, the context in which they live, and what they really want to do with it. And I always say that if we just focus on devices rather than people, we tend to make mistakes in what is the difference, especially in academic context, between what happened in research labs versus what happens outside in everyday life. We tend to function, especially in accessibility, we tend to get a bit too focused on the function itself for the sake of it, rather than what the person wants to do with it and what the meaning of using technology might be for them. And also because a lot of technologies get developed in very industrialized settings and tends to be developed in rich countries, we tend to create a little bit of a geographical disconnect and expecting things to work in the same way across context, which generally they don't do. I want to give you an example of this by referring to one of my favorite speakers. Her name is Haben Girma. It's an American lawyer. She is deaf-blind. She's a human rights lawyer. And she gave a brilliant keynote at the 2022 conference on accessible technologies run by the Association for Computing and Machinery. And I don't get to do this so much in this talk, but when one person gives a keynote speech, you're usually in front of an audience and you want to engage with that audience. If you're deafblind, it's difficult to see how people react to what you say and decide how you want to engage with it. So Haben had an observer that was looking out on what was happening in the audience. And this observer was feeding back information to her through like a digitized system. And she was using a Braille reader to get those information in real time and decide how to adjust that talk. So this is enabled by technology, of course, but you have to be able to get those information at the same time and basically like split your brain in two. One part is giving the talk and the other part is reading what is happening that is being fed back to you and adjusting what you're saying accordingly. So I think this is a very good example of how technology can support someone to do something that might be rather complicated, but only if the person themselves is equipped with sort of using that technology to do what they want to do in this particular context. One of the first example I want to bring up has to do with different work practices that happen through avatar robots. All of us during the pandemic probably became familiar with remote work. But in many circumstances, remote work is confined to types of jobs for which a physical presence to perform particular tasks is not required. In hospitality, this is very difficult, which means that if you cannot physically access a place of work, you cannot work in the hospitality industry. So I want to introduce you to one of my favorite places in Tokyo, which I have the very good fortune of being able to work in regularly. Is called Avatar Dawn Cafe, and is a place that is often referred to as a robot cafe. But it's a slightly different because the robots in question are actually avatar robots that are controlled from disabled workers who work from home. And we refer to them as pilots most of the time, and this is how I'm going to be calling them during this talk, because effectively what they do is that they manage very complex operation through their interface to be able to do all sorts of things that workers in hospitality do, from greeting people, explaining menus, taking orders, bringing food and drinks. And in one case that I'm not going to talk about today, but if you have the opportunity, you should check out. Also make you coffee on the spot. So in the Avatar Robot Cafe, there are two types of robot primarily. They're called both Orihime. One is called Orihime and the other one is Orihime D. Smaller orihime are about 20 centimeters tall. They are fixed on the spot, and they can move their head and their arms as well using predefined motion. These tiny robots are placed on tables, and they can be used to explain menu and get people's order. They're also placed at strategic locations in the cafe. So by the entrance, so as you enter the customer enters the cafe, the orihime robot will greet them, and the operator will ask you to sanitize your hands. They will then direct you to a manager orihime. The manager orihime will check your booking, and the operator will ask if you have a reservation or not, check if there is a table available, and show you where it is. The third step is the orihime that is placed on your table. This pilot will explain the menu to you and take your order and pass the order to the kitchen. Once your order is ready, the large orihime will enter in place. Large orihime are about 120 centimeters tall, and they will carry the food and the drinks from the kitchen or the bar to your table. Each of these avatar robots is controlled by a different pilot. So the problem with this system is that if you are a pilot that is assigned to a particular orihime, that will remain the same for the duration of your shift. Meaning, things can get boring because you do the same job over and over again. And your agency is quite reduced because you cannot follow the customers around as they move from sort of place to place. So the pilot asked us, well, people like servers, waiters in regular cafe can actually do this. Why can't we do it? And we were like, well, why not? So we developed a parallel avatar system that allows one pilot to control up to 4 avatars at the same time and switch between them so that as you enter the cafe and then move along and go to your table, it will be the same person following you around. That creates a sense of consistency in the experience of customers, but also really increases the agency of pilots. Effectively, what happens is that they're able to follow you from when you enter to when you leave the cafe. The thing with parallel presence is that there's 2 different aspects. One is functional, and I'm going to explain what you see in different screens here. So you have a manager orihime, and the customers are standing in front of it. What he's doing, he's explaining to the people where their table is. And is using the microphone from one of the avatars, but it's also using the movement from the others. So if you look at the central screen over here, you can see that the microphone at the bottom is unmuted. This is the one of the manager orihime that the pilot is using to talk. But at the same time, to signal where their table is also moving the arm of the small orihime placed on the table to say, hey, I'm over here. Because if I tell you that you've been assigned to table 2, you might not be able to find where that is at a glance. So the pilot started to leverage the parallel system to smooth the transition between one and the other. One aspect that is important to consider is that you have to be good at this. You have to be good at spotting opportunities where you can leverage the system in any way it's necessary to you. And you also, as the example from before, need to be able to manage the cognitive load that comes with this kind of interaction. One way to think about it is that it's very similar to media multitasking. So you need to process multiple streams of information at once. But if you're good at it, and our pilots were, you also spot opportunities to create playful interactions and entertain customers and have fun with this sense of multiple presence. So what you see in the slides here is a dialogue where one of the pilots is mimicking a conversation between 2 avatars, both of which are controlled by them. So as the orihime D is approaching the table, the pilot is using the small orihime to say, hey, we're here, can you see us? And switches the microphone to the other avatar saying, hello, I bought you some drinks. Then as the avatar approaches and delivers the drinks, is like, so did you enjoy talking to the customers? Switch off the microphone again. Yes, it's fun. As it turns around to leave, it also leverages movement from both of them, getting them to wave their hands at each other and saying, well, I need to go now. Bye-bye. So thank you. Bye-bye. And this is not something that we give people a script for, but it's something that they came up with it as they were using the system to find ways to entertain their customers. And it works really well because it creates this sense of surprise and sort of wonder. And we observe like very cool reactions from customers marveling at the fact that, you know, they were interacting with the same person through 2 different avatar bodies. So one of the things that I mentioned is that, well, if you want to use technology well, you need to be good at it. And to be good at it, you need to be taught in a way that you can understand and that it's suitable to what your access needs are. So many of you know that in many schools across the globe now, we're trying to promote what is called digital literacy. Now, this does not mean that everyone needs to become a software engineer, but technology has permeated many aspects of our life. And to be able to take advantage of it, you need to be able to understand enough that you can use it. Problem is that most digital literacy is done through programs, especially for younger children, like Scratch or Google Blocks or other things. All of these are great because they allow you to program and to do things without having to write, without having to understand and get bogged down in a lot of the syntax. But if you cannot see, you can't use this type of interfaces. Some of them might be friendly to screen readers, but if we're targeting this type of digital literacy programs to kids who are as young as 6 years old, they aren't going to be screen reader proficient. So what means is that we delay when people can access this type of digital literacy training. Now, Microsoft created a brilliant toolkit. It used to be Torino. It changed the name when it switched from being a research project to a tool available for certain schools via a program run by Microsoft. I believe now this is called CodeJumper. But what CodeJumper allows you to do is they have this beads that you can connect, and they have different functions. And you can learn about basic computational concepts using music. So things like variables, loops, sequences, all the concepts that form the basic of computational programming. Problem is that this tool can only be accessed through Microsoft. It's quite expensive, and it's not, which makes it not accessible to many. So we tried to develop a similar toolkit, but much more low cost and customizable. This is how we came up with Tiptoy. So Tiptoy is a tactile open source toolkit that follows the same principle of CodeJumpers. So it enables you to learn computational topics through music by combining physical blocks. Blocks are quite chunky, and they can be recognized by touch. They have tactile markers, or they can also be recognized by sight, as they tend to have high color contrast. They can also be recognized by sound. The way the system works is very simple. Each marker has a code. The marker, it's read by the camera, and you can use the system to do two things: either read aloud your sequence or play it as a music sequence. So I'll show you a short video, which is probably easier to understand. Each block represents a programming variable or an instruction. By arranging the blocks on the table, you can create simple programs. One push of the button reads out the program to you.
Play variable 6, play variable 3.
The other executes the program. All blocks are marked with tactile cues so that they can be recognized by touch, not just by sight.
play variable 6, play variable 3, repeat 3 times, play variable 1, play variable 5.
As you see, the system is very simple. We developed this originally with visually impaired developers, but we tested it with children with different level of visual impairments, and usually have them in pair with someone who was not visually impaired. So what we wanted to see was not just, is this accessible, but because school a lot of time is about integration, what we were really interested in was, is this a viable tool that two kids who have different visual abilities can use together and they can play with together? And what we observed was very positive, and that the learning style that children had were very varied, but the toolkit was simple and flexible enough that was suitable to pretty much everyone. What was interesting to observe is that the way children built code was extremely varied. Some were very conservative and used what I would call incremental iteration. So you put a block down, see what it does, put another one down, see what it does, and then sort of start combining. Whereas others tried to build sequences straight away and then retroactively debugging them. Modalities of collaborations varied between different children. Some had more fixed roles. So I do, you help me find the block, I put the sequence down, and then sort of maybe we swap. Whereas others were more fluid, and everyone did a bit of everything. And this was varied regardless of sort of what the difference in visual ability were. One of the things that were interesting, it was that children were able to not just learn about the computational concepts, but also errors that occurred, and gave us feedback on how we could improve and expand the system, from allowing people to record their own sounds, or spotting inconsistencies, like the fact that in our first version, of which you saw the video, when a loop closes the system wasn't used to tell you. So it was hard to understand until when sequences were repeated, and where different sort of a different sequence would start. Another project I want to touch upon, it has to do with, and it's completely different, has to do with a different style of manufacturing wheelchairs. To do this, I have to bring you to Kenya. So the way wheelchair provision works in Kenya, it's in two separate ways. Some wheelchairs are imported from the UK, from the States, different countries in the world, from China. And what you would like to see is that there is almost a direct supply chain from the manufacturer to the users, which proceeds very smoothly. This almost never happens. What you get, it's a massive series of stops in the middle that delays the fact of when you might be able to get a chair, how suitable to your needs that might be. Sometimes people get assessed, and they find out that they need a wheelchair with particular characteristics. But because for import duty reasons, shipments have to come in large quantities to be convenient, you might have to wait months for getting the chair that you need because your particular model or your particular size has run out. And until that shipment is finished and another one gets in, you can't get yours. So what you might think, it's like, well, why don't you make them locally? You can. The thing is that a lot of local production is done by hand. And what you will want to see, ideally, is that the quality remains consistent. What happens in reality is that the quality is immensely variable. You can get some great products or some absolutely terrible ones. I've been asked to evaluate wheelchairs that did not have all four wheels touching the ground, which you would imagine is pretty basic requirement. The work we did on this project was in partnership with a non-government organization called Motivation that has been active for over 30 years, providing suitable wheelchairs to people living in low-income countries all over the world. What they came up with is a parametric model where you can take someone's measurements, input them in this model that then gives you a combination of 3D printed joints and tubes, steel tubes that you can cut by hand to make the frame of the wheelchairs that perfectly suits the person. This means that you can get basic materials, but then make the wheelchair yourself, but do so with a consistent level of quality. The two main tools that you use is this simulator that allows you to sort of sit down the person with their required posture and take the measurements without having with a limited margin of error. The other thing that is very important on a chair is the seat itself. To create the seat and the backrest, we had a very simple system that had 3 potentiometers connected by a cable. That means that you can find the 3D coordinates of any space, of any point in space. We chose particular spots on a person's back that could be used to assess where support was needed. And you can see over there 2 different chairs that were made for 2 different users that participated in the trial, and the support system that come with it. We were interested in what is the acceptability of this model for both users, but also for providers. And one of the things is that people really appreciated that the chair was made according to their specification. The simulator also helps therapists to take the measurements correctly because it tells you exactly from where to measure, so that the margin of errors are very small. One of the things that came out is that the station where we were doing the measurements was still too difficult to access to people. So we wanted to try to find a way to get closer to where the users were, so that we could be even more accessible. From a wider impact point of view, what is important is that because the wheelchair is made according to your needs, you become better able to advocate for them. and you can have a more active conversation with your provider, with your therapist, about what you need and exactly what you want to do with the chair. And on the other hand, this also teaches providers how to listen, because as medical professionals, we're occasionally taught that we know better. And this can really get in the way. But with this kind of assessment, you have to listen. If you want to make a chair, you have to understand what the person needs. Last bit that I wanted to talk about before I stop is, and I touched on this at the very beginning, it's linked to some collaborations that I had the opportunity to do with artists who are different kinds of disabilities, use different kinds of assistive technologies. One of the things that we often think when we think about technology that is accessible or inclusive is about this functional gap between what a person might not be able to do and what they want to do. But this is not only the only important thing. Social consideration play a bigger role than functional one in having people decide what they're going to use and what they don't going to use. I am not going to use a wheelchair that makes me feel ugly. I am not going to use a digital technology that makes me look stupid. So how these technologies are perceived and how they embed in our social in our social world, but also the way in which they allow me to express my own identity on my terms. It's really what's going to shape what I'll use. So we started to engage more and more in projects that look at what I call the right to the frivolous. So beyond things that are importantly functional for education or for employment, things that have to do with play, fun, things that you want to do, but might not be necessarily sort of the lowest scale of the pyramid of functional needs. So we started to use Orihime robots for having play sessions. We started looking at how people want to have digital avatar representing themselves better when they play Pokemon Go. We started to look at portals for information about sex education in terms of pleasure for disabled people, not just in terms of not getting a disease or an unwanted pregnancy, but also how art can really allow to express identities in a way that doesn't just want to conform us from everyone else, but that really allows us to shine for what makes us different. So we had some collaborations with artists around using a combination of wheelchairs and virtual reality to play Pictionary as you drive around. A colleague designed a wheelchair that allows you to drift, that has been used by an internationally famous disabled dancer based here in Japan called Kenta Kambara. And we recently did some work with a wheelchair using DJ who's based in India, and to design sort of sets of wheels that will allow him to stand out as he performs by sort of responding to the music and sort of adapting light effect depending on the tunes that is played. So I've taken far too much of your time. I hope you find some of these things interesting. if you're interested in reaching out to me, please do so. I'm very bad at social media, but I tend to use Twitter sometimes, but I also have a website, or you can use my email here at Keio University to contact me. Thank you.
はい、ジュリアさん、ありがとうございました。とても興味深いお話をたくさん聞かせていただいて、もっともっとお話を聞いていたいところなんですが、それでは、質問がですね、1件届いてますかね。じゃあ、柳川さん、質問をお願いいたします。
Okay, we have one question from someone. How many instructions can be strung together in Tiptoy, and what's the longest? So, how many of them can you connect?
So at the moment, the longest sequence is 12 different instructions. We also have a student that is looking at allow you to save a set of instruction and add more to expand what you can do. But one of the things that I am keen to highlight as a limitation of what I perceive tactile interfaces to be is that at a certain point, you want people to transition to text-based things because they're more powerful. So there is an element of us wanting to add the possibility of doing a little bit more. But at the same time, I do think that tactile interfaces are meant to be sort of an entry step. And that at a certain point, we want to facilitate how people move to sort of bigger and more sophisticated things.
Oh, thank you. We have another question. How much money can be saved for the Canyon wheelchair purchaser by using the 3D printing?
So that's it's a bit of a complex question because it largely depends on scale. So at the moment, what we were interested in is, can you offer a better product without increasing cost? So an average wheelchair with sort of like importation and things like that cost about, from top to bottom, about $250 at the least. That can cost a lot more, but for a basic chair is about $250. We're able to match that, so not make it more expensive. And it has technically a lower carbon footprint as well, because I mentioned that we use steel tubes, but in another of the region of Kenya that Motivation is currently working on, they struggle to get steel tubes and they're more likely to get aluminum one. They're perfectly suitable as well. So you can adapt things a little bit depending on what is available around you, which is quite an important feature, not just for the initial manufacturing, but for repairs as well. Because one of the issues with imported chairs is that if it breaks, then you might not find anyone that can repair it for you, which it's doubly problematic.
Thank you. I personally have another question.
Mm-hmm.
I think 3D printed parts tend to be easy to break, less durability. But how durable is the 3D printed wheelchair, and does the easy fix overcomes the difference between the non-3 standard wheelchair?
So the 3D printed parts, it's true that 3D printed parts tend to be less durable. They're particularly susceptible to shear forces. The way that they are printed is to minimize that as much as possible. So, for example, we only print joints. It will never make sense to print like a longer part because it will break. They can also be reinforced using different kinds of layering. So when we did the testing, they passed all the ISO testing, and users did not sort of report problems with it. There is a question of weight. So at the moment, the parts are suitable for someone who is at most about 100 kg in weight. We had participants who were heavier, and we observed bending over time, meaning that we ended up switching them to the other kind of chair that Motivation provides. One of the reasons why we partner with this kinds of organization is because when you try innovations, they might work or might not. If they don't, it shouldn't fall on the skin of the participants. So you have to provide a suitable alternative, which is what they would have otherwise gotten anyway. So that's very important when you try this kind of innovations, that if things don't work out, people still have the opportunity to fall back on the traditional kind of sort of assistive technology, or wheelchair in this case, that they would have gotten otherwise.
I see. Thank you very much. I think it's time for breakout rooms. So I'm going to hand over the mic to Makoto-san.
はい、ありがとうございました。私自身はですね、普段はウェブコンテンツ、ウェブサイトやモバイルアプリのアクセシビリティに取り組んでいるんですけれども、支援技術と聞くと、スクリーンリーダーとか画面拡大ソフトとか、あるいはマウスやキーボードの代替デバイス、代わりになるデバイスなどがすぐに思い浮かぶんですけれども、今日の話を聞いていて、すごく視野が広がったといいますか、身近なところでも、なんですかね、デザインとか設計思想とか、いわゆるテクノロジーだけじゃなくって、デザインだったり設計思想だったりっていうのが、社会の問題を解決したり、あるいは今までできなかったことを可能にしてくれたりする、なんかすごいそういう可能性みたいなものをたくさん感じることができました。ジュリアさん、今日は本当にありがとうございました。
ありがとうございます。
はい。